Hello, welcome to Algorithm. Today we'll be solving Leetcode 767 Reorganize String. This question gives a string S and we have to rearrange the characters such that there are no two same adjacent characters. So in the example, we can see that we have AAB, right? And these two characters are adjacent to each other and they're the equal characters. So therefore, this is not a valid string. So we can reorganize it to be ABA, where no two characters that are adjacent to each other have same characters. Now, often when examples are given, you have to carefully observe these examples because typically the examples give a lot of hints on how to solve the problem. Through example 1, I was able to observe that if we try to use B first to reorganize the string, there's no answer to this question. We always have to use A first. And I wondered, why is that? And I realized that it's advantageous for us to use the most frequently occurring characters first. So we use A first because there's two A's in total, right? And then we use B next because that's the next most frequently occurring letter. In the second example, I was also able to observe that A is more than half of the characters in the given string, right? There's three A's and there's only four characters in the string. So I realized that it's actually impossible to rearrange when there's more than half of same character. I wanted to confirm this, so I looked back at my example 1 and I realized that here we actually have more than half of the number of characters in the string, right? A is 2 and the total length is 3, right? So I realized that if the given string is an odd number of characters, we have to round up, and that will be our limit of how frequent a letter can occur. So 3 divided by 2 is 1.5. Rounded up, it's 2. So no character in given string S can't have a letter occurring more than 2 times in the given string. If that's the case, we return empty string. Through these two examples, I was able to observe huge hints into solving and figuring out the solution. So to solve this question, I realized that first, we need to count how many letters there are in the given string. So let's, for example, think of character A, right? Then we would store this and get count. We would get how frequent these letters occur in the given string. And these are typically done through hash maps. So I realized that I probably more than likely need hash map in order to solve this question. Then I also noticed that we have to order them in how frequent they occur, like such, so that we can pick out which character we want to use next in order to reorganize the string. Next, I'll try to iterate through the given sorted list like a program would so that I can see if my approach of solving the question would work as a program. So let's start with the resulting variable, empty string, and with the given sorted list, right? Now we'll add the most frequently used character, A, and then we'll pop the A out of the sorted list because we don't want to use A again because we don't want adjacently equal characters. So we go to the next one. I'll copy the previous iteration before I process it in the current iteration. So the next most frequent character is B, so we pop B out. We add it to the resulting string. Now we want to add A back into the sorted order list because we only used one out of three A's in the given string so far. So we all not only don't do we want to sort the list, we want to maintain the sorted list through insert and remove, right? Key point that I realized to myself, and I'm thinking about it in my head as I'm doing this. Now I'm gonna add the next most frequent letter, A again, right? Not C because A occurs twice. A have the remainder frequency of 2 and C has the remainder frequency of 1. So we add A again, we pop it out, and we add it to the resulting string. Now we add B back into the sorted list because we want to have one more B into the resulting string. So I'll copy the previous iteration once more. Now we're going to process this. We're going to get the most frequent character, which is B. We pop it out of the ordered list. Now we have A one more time. We add A back to the sorted list, and we go to the next iteration. It's very repeated work, but I'm sure you can see what's going on. Just in case you don't, I'll just do it until the end for the given example. So here we get the most frequent letter, A, we pop it out, right? Now we realize that we don't need to pop in the previous letter because B, the previous letter, we only have 2 in them, right? And we already used all 2 of them, so we don't need to do anything. We go to the next one. We add the next most frequent letter, C, and then we pop it out, and there's nothing else to pop back in, so we return this, right? So this is how you would solve. So if you look at here, so through just writing it down and trying to process it like a program in my head, I was able to figure out that I have to use hash map, and I had to have a sorted list of unique characters that is sorted by the frequency of it, and we have to make sure that we have to maintain through insert and remove. Now this indicates to me that I should probably use max heap to solve this problem. Now we have all the tools to solve the problem. Let's go to the coding part of the problem to solve the question. As I said, we need a hash map of count of each unique string, which will be very easy. There's actually a library built in called counter, and we just pass in the string and it will save the hash map of each unique letters and the count of it. So next we'll create a max heap. We'll iterate through the unique characters in the string through the myCount variable. I will first add everything into the list. I'll add the count, and the corresponding character into the max heap, and then I'll heapify it, heapq.heapify max heap. Notice how I did it I used heapify because this is actually a big O of n operation, which saves which optimizes, which is more optimized than using heap push here, because what will happen is it will be n log n, right? Because we'll be heap pushing n times, right? So that's why I do it this way to save a little bit of time. Now our heap is built. We make our resulting string. Now I'll be using a empty list and then I'll operate on it and then return join like so, because string operations are generally not efficient. It's better to use the list to build on it because strings are immutable objects. So also we talked about how we have to keep track of the most recently used characters. So prev count and prev character equals 0 and empty character. Also, just a nuance for heaps, we want to use the negative value because in Python, we can only organize heaps through min heaps. So we just flip the values to be negative to make it a max heap. So we just have to make sure we are aware of that every time we operate on it. So we loop through the max heap. We get the cur count and the cur character by popping from max heap. We append it to the list, the resulting variable, current character, and then we add 1 to it. We increase the current count. Now we check if we have to operate on the previous character. So we'll check if previous character has count of is not count of 0, meaning that character has occurred more times in the string, so we still have to use these strings. We add it back to the heap. Now that we added, we update the prev count and prev character to be the current one. Now the current, and I think that's it. Oh, I must have a typo here. Let me check. I do. I'll run again. Oh, yes. So I forgot a little bit of code. So I think we talked about how we observe that if a given character occurs more than half of the characters in the string, then it's invalid, meaning that we return empty string because it's impossible to rearrange it. So let's get the most frequently occurring character. So if we get 0, we get the maximum count. Also, we want to make sure we turn that into a positive number because we added them as negative. And then we want to check if length of s divided by 2 is we want to check the ceiling, math.ceil, length of s divided by 2 is If this is the case, we return empty string. Now we'll actually run the code. We have passed the test. In conclusion, for the time complexity, we're counting every character in the string. So this is a big O of n, where n is the length of the character s. And then we're going through unique characters. So let's let k be unique number of unique characters. Then this operation is O of k here, right? And then we heapify, so that'll be k. So k. And then this loop is O of k log k, I think. Actually, it'll be n log k here because we're doing heap push, which is log k, but we're doing it n times here. The loop will run n times because the heaps won't disappear unless we iterated through every single character at least once. So adding that all up, it'd be the biggest one would be n log k. So the time complexity is n log k. And then the space complexity will be O of k, where k is the number of unique characters in the given string. So time complexity equals O of n log k. Space complexity is O of k, not including the resulting variable. Thank you very much.